What I'd like to look at next is the overall decay process. In other words, as we add organic material to the soil, what happens from a chemical composition standpoint to the composition of this material. We're going to utilize a simple formula for a carbohydrate, like a simple sugar such as glucose, to illustrate this example. So the overall decay process tells us that if we take a simple sugar like glucose that has a chemical ratio of C6H12O6, it has to be oxidized. In other words, this breakdown microbial decomposition process is an oxidation process. Free oxygen is required. So we combine that glucose sugar with oxygen in the presence of the microbes which are causing this decomposition. We also have to have adequate temperature and moisture. And this material is going to be broken down into carbon dioxide, water, and energy. So in other words, these more complex organic molecules are going to be decomposed into their basic components, in this case carbon dioxide and water, if this is an example of a carbohydrate, and the energy is going to be produced as a result of this. Well, where does this energy come from as a result of the breakdown of this carbohydrate type of material? Well, that energy is coming from the breaking of the chemical bonds that exist between the atoms in this particular molecule. So as we break down chemical bonds, energy is released. These microorganisms are doing this because they're looking at this as a source of food, and they're also looking at it as a source of energy. That energy, at least a certain amount of it, is going to be picked up and utilized by these microorganisms and or stored in the form of ATP, the chemical energy storage compound that exists in plants and animals. Now, obviously, the only thing found in these plants are not simple carbohydrates like glucose sugar. We have the proteins, we have the lignans, we have that group, the fats, the oils, the waxes, and the resins. So there are going to be many things broken down other than just the simple carbohydrates. But the basic process is going to remain the same. We're going to get carbon dioxide and water evolved, and we're going to get energy produced. In addition to that energy that's being produced, many of the nutrients, or I should say many of the nutritional elements that are contained within that organic plant residue are going to be released in mineralized ion form. So I'll refer you back to the earlier handout on the organic matter decay cycle or process, and I'll refer you to the two terms mineralization and immobilization that we discussed earlier on this tape. Those elements, such as nitrogen, that are contained in this organic residue, those that are there in excess of the needs of the microorganisms that are breaking down the residue are going to be mineralized or released in simple ion form. Nitrogen is typically released as an ammonium ion, NH4 with a charge of +1. Sulfur as sulfate, SO4 with a charge of -2. Phosphorus as some form of phosphate, HPO4, H2PO4, etc. And the other metallic cations that are contained in this plant material, such as calcium, magnesium, potassium, etc. Those are going to be released as simple inorganic ions. So the breakdown of these from complex organic materials and the release into simple inorganic ion form is called mineralization. And it's a very, very important process to our crops that these microorganisms have the ability to mineralize, break down this organic material, and release these nutrients that are held there in a form that can then be taken back up and recycled through the next generation of plants.